All right, guys. This is video 216. That's our sixth video of our first standard in Unit 2. Again, we are working on graphing and identifying key characteristics of linear and piecewise functions, and we finally made it to the piecewise functions. What the heck are those? Well, that's exactly what we're going to start with. So this is graphing piecewise functions. So you're definitely going to want to take some good notes, so make sure that you're ready. We're going to talk about how to do this on our calculators when we're together in class, so you don't need your graphing calculator to do this. We're going to be working with it pretty much just on pencil paper today, so get ready to take some notes. So exactly what is a piecewise function? A piecewise function is a function that is made up of multiple parts, multiple pieces. Okay, we're going to start with 2. They can graduate to 3 or 4 or 5 or 100 really, but this is representative of different parts of a whole function, but they really need to be made up of different line segments, or they may look like rays, so if you remember that from geometry. So definition isn't so important as long as you know what we're identifying different pieces of a single function. With that being said, I'm going to sketch one without any skill or any knowledge required to know about piecewise functions, exactly what one of these may look like. So I may see an open circle somewhere, and then I would see a line that would be drawn from that in one direction, and then maybe I would see a solid circle below it. Then this piece, maybe it's a horizontal line and it ends right here with an open circle, and then I have a closed circle somewhere else, and this one is another line that goes this direction. All right, now this is 3 pieces of a piecewise function. I've got piece number 1, I've got piece number 2, and I've got piece number 3. They could be ordered in any ways. I'm just how I can refer to them. What you notice, though, is that the pieces do not, between the 2 pieces, there is an open circle and a closed circle. That is because we are defining here a function. If both of those circles were closed in, then that means that this x value of -5 would be assigned to 2 different y values, and that breaks the rule of being a function. So we must have, one of them has to be open. Could both of them be open? Absolutely. They can never both be closed. All right. Then we have to look at the fact that each of these pieces has their own slope. Each of these pieces is different. Each of these pieces could technically have their own y-intercept if they were permitted to continue. So that's going to be the basis of how we graph these piecewise functions. Notice for this piece over here, I'm going to highlight it for you. For this particular piece, we're talking about all the x's that are less than -5. For the piece in the middle, let's get a different highlighter. For the piece in the middle, this piece is discussing all of the x's that are inclusive from -5 up to +1. I'm talking about the x values that are being associated with this. And the last piece are all of the x values that are greater than 1 all the way on to infinity. Again, I'm talking about the x values. You're like, but this line stops. No, it doesn't. It keeps going. So that means all of these x values will eventually be used. All right, this kind of gives you an idea of what a piecewise function might look like. Let's go ahead and try graphing some. The first thing we're going to do is we're going to make some tables and graph some points. So I'm going to write a piecewise function. It will be the function of x equals these pieces. The first piece is x plus 4 when x is less than or equal to 2, and 1/2 x minus 3 when x is greater than 2. So this is the when part. These are the intervals. When x is less than or equal to 2, when x is greater than 2. Okay? We're going to make some tables. We're going to make a table for the first piece, where we have x and f of x, and we're going to have a table for the second piece for x and f of x. I'm going to use 2 as my value here, and it's going to be included. I'm going to use numbers that are less than 2 now because it tells me to use x is less than or equal to 2. So how about 1 and 0 and -1? This will give me a good picture of what that looks like. And then I'll substitute the numbers in. So I put in a 2 and I get a 6, put in a 1 I get a 5, put in a 0 I get a 4, put in a -1 we get a 3. This allows me to start graphing that piece of the line. Then I'm going to go ahead and make a chart for the second piece. These values need to be greater than 2, but I'm going to use 2 so that I can figure out where that open circle is going to be. If I don't use 2, and I know it says it's not included, I know it's not included, but I need to know where to put the open circle. So I use the 2, and then I choose numbers that are greater than 2. I'm going to use a strategy so that I don't have to deal with this 1/2, and I'm going to use all even numbers because when I multiply by a half, I know I'm taking care of them. So here's my even numbers that I will substitute in. 2 goes in and you get a 1. 1 minus 3 is -2. Put in a 4. 4 times a half is 2. 2 minus 3 is -1. Put in a 6. 6 times a half is 3. 3 minus 3 is 0. And you can guess that this is probably going to be a 1. Now we're going to graph. I'm going to start by graphing this first piece, by graphing the 2, 6 with a solid circle. And then all of these circles, every circle on this, every dot, every point is included in the line. The only point not included is the 2, -2 because it's an end piece. Okay, so everything else is included. 1, 5, 1, 5, and 0, 4, and -1, 3. And these are continuing on in the negative x direction because I want to go less than or equal to 2. So that's all of this side. The other side is going to be 2, -2 with an open circle, 4, -1, 6, 0, and 8, 1. And that is this piece. So this is our first piecewise function that we've graphed. We're going to try one more. F of x equals, this one's going to have 3 pieces. The first one's going to be a -2x when x is less than -3. Then we're going to have one that's just a 5 when x is between -3 inclusive and between up to 2. And then our last piece is going to be just a simple x plus 1, and we're going to have that one be greater than 2. Okay, please note, I'm not including it in 2 places. So the -3 belongs, inclusive to here, whereas the -3 is exclusive and the 2 is exclusive here. So this one's going to require 3 charts. Our first one, we want to use the -3 just so we know where the open circle is going to be. Not because it's included, but because it just needs to be represented. Then we want to choose numbers that are less. So how about a -4 and a -5? That's plenty. So I put the -3 in and we get a 6, a -4 gets me an 8, and a -5 gets me a 10. The next piece, okay, I'm going to choose numbers between -3 and +2. They're both included, so I certainly want to use those two so I can get some solid circles. But maybe I'll just choose something in the middle. How about 0? Okay, well, since it says f of x equals 5, and there's nowhere for me to put the x, that means that they're all going to be 5s. F of x is always 5 for this piece. The last piece is x plus 1, where we choose numbers that are greater than 2. But again, we're going to use the 2 even though it's exclusive just so we know where to put the open circle. And then I can substitute in other numbers like 3 and 4. So let's put those in. You put a 2 in, you get a 3. Put a 3 in, and we get a 4 and then a 5. And let's graph that. The first piece, negative 3, 6. I should get music playing while I'm doing this part. Oh, shoot! See, I wasn't even paying attention. Darn it. That's supposed to be open, Miss Moran. Negative 3 and 6. There we go. Then I have negative 4, 8. And negative 5, 10. All right. There we go. Now we can graph this middle piece. And this is negative 3, 5. And 0, 5. And 2, 5. Oh, that's a horizontal line. And both of those ends are included. Okay. That was a very bad horizontal line. And then the next one is 2, 3. And I want to make sure this one's exclusive. And then 3, 4. And 4, 5. And it looks like this. So there is our second piecewise function that we've graphed together. All right, if you've got any questions, let me know. And you can put those on Schoology. And we will chat when we see each other next.